Hi everybody, in today's lecture we're going to be introducing two other data types, namely the character data type and string data type. Of course, you know that by data type we basically mean variable. So two different variable types. Character or char, I have talked about already, and string I'm going to introduce in these lecture series. Basically, in processing, char is 2 bytes or 16 bits. It will hold only one character. So any character confined between single quotations is called a character constant. So it's basically a character. So the way we would introduce this is just like we would do anything else. So if we have int a equals 10, we can have char, actually let me write it in a different color, can have char, and the variable name could be anything, ch, and we initialize it using the quotation, single quotations, and it could be any letter or any symbol on your keyboard. So let's just say uppercase A. In the memory diagram, we're going to have A, and it's initialized to 10. CH, it's initialized to capital A. Please notice that we do have single quotations here. So if you put double quotations for a char, you're going to get an error. Also, only one character could be held inside a char. So you could not do something like char, let's say, my char as a variable name equal, let's say, AB or AA. This is all very, very wrong, right? So you could never have something like that. Just as it is in the case with all other variables, you're going to have this is the identifier or type of the variable, whereas ch is in this case the name of the variable, and that's pretty much it. In terms of using a char for everyday application. So for example, if you're filling in an application and it's asking for gender, male or female, you would put it inside a char, or like a middle initial would a char variable would hold that data. So it's very minimalistic. We're going to see more use out of a char when we start talking about strings. There is something else that I want to talk about with chars though, and that's what makes the topic a little bit more interesting. Going back to the slides, it actually reads, in processing, char type is a 2-byte integer. So this is kind of interesting. But looking back at everything we've learned, this should make perfect sense because, as you recall, computers don't understand letters. They don't understand what A is. They don't understand what B is. They do understand series of zeros and ones. So if you recall us having the ASCII table, with the ASCII table, we assign a number to each keyboard character or to each symbol. For instance, we have A as 65, B is 66, C is assigned 67, and of course each of these numbers are converted to binary. So for example, here's if you see the ASCII table, you see a whole bunch of characters that a lot of them we don't really know. I mean, you see some of them. So for example, the escape keyboard, this would be this has the number 27 associated to it. Space is also is regarded as a character, and that has value 32. The numbers on the keyboard, so aside from the mathematical numbers, when you look at them as a character, they've been defined as from 0 to 9, and they actually have values starting from 48 and so on and so forth. The letters, they start from capital letters from 65, so 65 all the way to 90 for capital for lowercase z, and then from 97 all the way to 122 for lowercase z. So if we go to processing, we can actually see. Let's do some programming with processing involving variables, involving chars. So if I have char ch, and if I have char ch first of all, and I want to know what is inside of ch, I'm going to print it. What do you think is going to happen? What's inside of ch right now? So I haven't initialized it, I haven't assigned it, so what's inside of it? Garbage. So when I try to run it, I actually get an error. It says that this variable hasn't been initialized, there's nothing in it, you can't print what's inside. If I go ahead and I say, okay, well, let's initialize this to uppercase A. Now if I run it, A is printed. So A is inside of ch. How do I get to see the decimal value that's actually stored? If I want to see the decimal value of this char character, of this ch character, what I do is I actually convert it to an int. So I basically typecast it, and you guys recall typecasting from the previous lectures, to an int. Now when I run it, I get to see the ASCII value of A, which is 65. Let's do another one, a little bit more random. Let's do, for example, lowercase h. Let's see what the ASCII value of lowercase h is. It's 104. Let's go back to the ASCII table, lowercase h, and we see lowercase h right over here with the value 104. All right, let's work with this a little bit more. So let's say I have ch, and then I would say ch equals lowercase a plus 1. And here I'm just going to say what is in ch. So what happens? I'm basically saying ch is going to equal a plus 1, character a plus 1. So this is not a variable. Remember, this is a character because it has the two quotations. So if I run this, B gets printed out. Why is that? Let's look at this a little bit more closely. So if we have char ch, draw the memory diagram, ch right now, it's garbage. If I say ch equals character a plus 1, what happens is the computer says, oh, character a. Character a, it looks at the ASCII value of it, and we can do the same thing. My apologies. So ASCII value of lowercase a is actually 97. So this is 97. So it says, okay, so this is 97 plus 1. That's 98. And it puts it inside a char. And 98, when you try to put this inside the char, it gets saved as 98, which is a B. So this is saved as lowercase b, right? So if we go to processing, we run this, and we get value b at the bottom. Oops, it jumped. So, be advised that this is different from a variable a, right? So, this is not a variable, this is a character. So if I have an int a, this is character a, that's variable a. They're completely different. This has the single quotations, right? Another thing that's a little bit interesting is what happens if I, let's just say ch equals a. Okay, we're good with that. Then I said ch plus 1 inside my print ln. What do you think is going to be printed? So this is a little bit tricky now, right? Let's try to run it and see what happens. Oh, we get 98, which is the ASCII value of lowercase b. Why is that? This is because println does the calculation and then prints out the result of the calculations, which is 98. So it doesn't convert it to a character anymore, right? So let me write down the two cases. In the first case, if we said that we're going to have a char ch, and let's say we say ch equals to lowercase a plus 1, and then we try to print out ch. The second case was that we still had a char ch, and here we had ch equal to, let's say, a, and then we didn't assign anything to ch anymore. We just tried to say, well, print out, let's say println, what is the result of ch plus 1? This is going to print what? We said that this is going to print b. This is going to print 98. The reason is that here you do the calculations. So here the result of this calculation is 98 because the ASCII value of a is 97 plus 1. And you put the results inside of ch. When you put the result inside of ch, you automatically convert it to a letter. So there is a conversion involved here. Here, we're just doing math, essentially. So you're saying ch, the ASCII value is 97 plus 1, that's 98. There is no conversion because you're not reassigning it to a chart anymore. You just print out the results of an arithmetic, basically. So do some more playing around with this, and it should start making sense. It's a little bit convoluted because you convert to a number and a letter. Do some playing around with it. Maybe watch the video again. Make sure you follow my example. And if you have any questions, ask us. Please ask us. There is a question for you to answer, and we'll continue after that. Okay, I want to finish this video with another example, a bit of an arithmetic example. So if you have, we can actually see the difference between two chars. So for instance, if I have an int x, for example, I could say, well, what is the difference between uppercase A with lowercase a and uppercase a, and I could do this and actually save the result in x. So now if I print x, the difference between those two will show, and the difference is 32, which makes sense because this is basically saying what is the difference between 97, which is the ASCII value of lowercase a, and 65, which is the ASCII value of uppercase a.